Today we will be doing a chapter about header files, libraries, storage classes, conditional compilation. And in fact, yesterday I took this out. Okay. So the personal libraries, C storage classes, conditional compilation, arguments, function, main, defining macros with parameters. These are the chapter topics. So I will talk about these. And let's start from this personal libraries, header files, and implementation files. Okay. So far we have been using standard libraries like string library for our benefit to do our things. String library is very useful, as you know, but we know that most of the functions are very simple. I can write them. In fact, we implemented many of them, right? We have implemented many of them. But they made a small library for the strings only, and they made it available. Whoever needs it, they just include the string.h, right? They just include string.h, and they use it, and they linked against the string library, and they are happy, right? So why don't we write such libraries ourselves, okay? And that's the idea, actually. If you are designing large projects, okay, that's the way to go. And in fact, they assigned your term project today. You have more than a month to complete it. I think you have 35 days to complete it. And that large project asks you to write a number of libraries, okay, a number of header files, a number of implementation files, and etc. Of course, you are going to do the main design yourself, but I gave you kind of a overall structure of the whole project. Read it. If you have any questions, ask me, the TA, or your tutor. Okay. Today we are going to write our own libraries, and I'm going to show you how to use them in your code. Okay. So to do that, usually we start a new project, and today I am going to do this. Okay. Since we know about structs. Okay. I like to write. Okay. I like to write some functions that would be useful for doing rational arithmetic. What is rational numbers? Like I like to add 1/2 plus 1/3. Okay. I like to multiply these two, and it should give me 1/6, right? So you might say that why do we need them? Why do we need the rationals if we have the doubles? Well, I mean, rationals are sometimes more capable of doing things than the doubles, because maybe I can represent 1/2 is really 0.5, but what is 1/3? I don't have the corresponding number in doubles, right? Maybe you would say 0.33333, but I don't have infinitely many decimals here in any programming language, right? And this is just an approximate number, just an exact number, okay? So if I multiply 0.5 times 0.33333, I don't have to get this number 1/6, okay? It might be different. Remember what we said about the doubles? They are not exact, right? They are not exact. But the rationals are exact, okay? When you say 1/2, it is 1/2. 1/3, it is 1/3. So it would be a nice thing to have a rational library to do things like, for example, I like to do things like, let's say I'm going to do a type def for rational, okay? I like to do this, a function that returns a rational number, add rational, okay? I will take a rational, the first one, rational R1, comma, rational R2. And it would do something, 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 and it would return a new rational. Okay, it will add these two rational numbers. That would be nice, right? So add rational, subtract rational, multiply, divide. Okay, convert to double, from double to rational, and etc. and etc. These kinds of functions would be nice, and I would put them in rational.h. Okay, I would put them in rational.h. Of course, I need this rational thing. I think it would be something like struct. Okay, uh, type def struct integer a, integer b, and I guess that will be it, rational. So I define the rational struct. It has two things, a and b, right? A and b. That would be a thing. That would be my kind of the new type definition of rational. This add rational would take two of them, etc. and etc. Okay. Of course, you might say that. How about the cases where the rational is not valid? For example, when b is 0. When b is 0, the rational is not valid. So maybe our function should be careful about that, and etc. etc. Or you could say, well, I know 1 over 2 is equal to 2 over 4, right? So what am I going to do about this kind of stuff? These are all details that you need to make a decision on, but I am not going to talk about them yet because I'm going to ask one of our LLMs to write the prototypes for us. Okay, the prototypes for us, the function prototypes, and then I am going to ask it to implement. Maybe we are going to implement one or two, because my purpose here today is not to write a rational type def or implement the function. That would be nice, but I don't have time for that. I'm trying to show you how to write libraries and use them. Okay, so let's ask Cloud to write a rational uh, header and the library for us. Okay, let's ask Cloud to write these functions first. Let's go to Cloud or ChatGPT, whatever, doesn't matter. Okay, write a number of C functions to implement rational operations such as add, subtract, multiply, divide, inverse, to double, to rational, etc. Okay. By the way, why do they call it rational? Why do they call it rational in English? Yeah, it is a ratio of two integers. When you say a over b, it's a ratio of two things, right? So why do we call it rational in Turkish then? So somebody messed up, right? Somebody, I don't know who made that decision. The correct term for Turkish shouldn't be rasyonel sayılar. Maybe what is the correct term? In middle school, in primary school, they teach you as rasyonel sayılar, right? Is that correct? They shouldn't teach you like that. They should maybe kesirli sayılar. Kesirli is better, right? Because this is kesir, right? Yeah. So I don't is kesir Turkish? Let me ask ChatGPT. But if I ask ChatGPT, this is going to gone. This is going to be gone. Let me delete this. Is kesir Turkish? The word kesir, it looks like Turkish, right? Because it is. Yes. I mean the root of the word. Does it come from some other language. Anyways, if it is Arabic or Persian, doesn't matter. Kesirli sayı is much better than rational sayı. Rational sayı is not, rational is not, no, it is Arabic. Kasr. It comes from kasr. You know Arabic? Do you know Arabic? No, you don't? Do you know this word kasr? No. Anyways, rational is not Turkish anyways. It's a wrong term anyways, okay? So why do we call it rational sayılar? I don't know. Okay? There is nothing to do with rationality. It is ratio. Okay? So whatever. Okay, so I'm going to come from our linguistic word coming to the C programming word. I'm going to write this. Okay. Write a number of C functions to implement rational operators such as etc. etc. So it's going to write it. I'm going to take all these functions. I'm going to inspect them one by one, maybe. Okay, how it is written. I mean, these functions will not be very difficult to write, right? I mean, the most complex of them would be maybe 10 lines long. Oh, okay, it is first saying that I am going to give you the header file. Okay, well, it will be clear in a few minutes what we are doing here. Okay, it is producing it, and let me go to the okay. Okay, let's open our Linux window, and I will make a new directory to put all those files in it. Okay. Make new directory, regional, and open up Explorer here. And let's not forget about, okay, let's make a new file. How am I gonna make a new file in not metin belgesi, but I like to make it. Okay, let's go to Notepad. While it is producing all that stuff, let's make a new file and save as, yeah. Oh, good. Okay. So the rational is a directory here, and I am going to make this rational.h. This is going to my header file, and my header file, C source. Do you guys see the header file thing? Why do they have to be at so different places? C source code. Okay, let's go to H. Do you guys see it? C header file. All types. Okay, rational H. Good enough. Okay, so this is my rational H, and then I will make another one for rational.c. Okay, That's how we do things. So we write the header file, we write the rational.c. And before we fill in, okay, let's make the new one. New what? Okay, rename this one rational.c. Okay, let's go to cloud again. Cloud says that, okay, things are ready. Okay, this is rational.h. As you see, instead of saying A, B, it says numerator and then numerator. And then, yeah, why don't we just copy everything and paste it to our rational.h. Okay, so start from the beginning. I'm going to ignore this line for these two lines first now. Okay, it says that I'm going to use standard Boolean, etc. I ignore that one too. So this is my rational type def, numerator and then numerator. This function is interesting. Make rational, it takes two integers and it makes a rational out of them and returns it. Okay. Why do I need such a function? I mean, isn't that enough to say things like, since this ration is defined, right? All I am going to do is define in my C code, I'm going to say rational R1, right? Comma R2, and I will say R1 dot A is 1, R1 dot B is 2. Okay, so that's what I did. 1 over 2. And I can do anything that I want. I mean, R1 is assigned R2, etc., etc. This one says that, no, don't do that. It says, don't do that. It says R1 gets the value of, what was the name of the function? Make rational. Make rational 1, 2. Okay. It says, no, don't do that, but do this. Do you see any advantage of calling such a function to make any rational? And in fact, I remember this one. I could have said R2 will be initialized by 1, 3, right? I could have said that too, right? I can use the initialization for the structs. So I can do it this way. So I say that don't do it this way, but do it this way. What would be the advantage of such a thing? This is a function call, right? So how do you implement this function? Basically, in this function, let's implement this function. Rational. I'm going to make rational. It will take integer A, integer B, and I will make a rational R. R dot A gets the value of B A, R dot B gets the value of B, and return R. That will be it. That will be the whole function. So why did we write it? Can I make this function better? A little bit better. How? Maybe I can do such a thing. Maybe if I say if B is 0, if B is 0, I am in trouble, right? I shouldn't maybe allow it. What should I do? What should I do? If B is 0, what should I do? Don't let this function run and maybe exit from the program. No, that's not a good thing. Maybe if B is 0, maybe I should do this. I am going to something bad, but it is better than this one. I am going to make this A is 0, B is 1, so that this rational is equal to 0, right? So that's what I did. And I'm going to return that R. So, and in my comment, I will say that if the given AB is not valid, a value of 0/1 will be returned. Maybe I should say that, okay? So I made sure that whatever I am forming is a valid rational all the time. No invalid rationals will be allowed, okay? So that function maybe is good for that, right? Okay. Create a rational number from numerator, and the numerator automatically simplifies and ensure the numerator is positive. Oh, okay, see this one? It say that if somebody gives you 2/4, it's going to make it automatically 1/2. So it will simplify it. Okay. And what happens if both a numerator and denominator A or B are negative? I will not allow it. Okay. Automatically simplifies and ensures dominator is always positive. Numerator can be positive or negative. Okay. So that's how we represent rational numbers. So we defined a number of rules. Okay. So this make rational will make sure that we follow those rules. Okay. So interrational, this one will make a rational out of this end. So how would you write this? Interrational. How would you write this? Just yeah, A is n, B is just 1. That's it, right? That will be it. Okay, how about the double rational? Okay, double iteration is going to take 3.5, for example. I like to convert to a rational. How would you convert to rational? Okay, so 3.5, it is easy. What do I do? Multiply it by 10, so 35, right? So it's going to be 35 over 10, right? That will be our double the rational number. And this one say that your number may get, how about this one? 0.123456757, etc. It's a very large number. So how are you going to convert this to a double? Well, you need to multiply it with a very large integer. What is that largest integer that you like to know? That's the max denominator. Okay, so this is the rational to double. Basically, what you are going to do is just divide it. Yeah. Can you do this, make rational? I mean, you are saying that call make rational inside this function. Is that what you're saying? I make rational too. That would be confusing, right? I mean, this is better integer to rational, and double to rational is self-explanatory too. But if you do things like make rational, make rational, make rational, if you call all of them make rational 1, 2, 3, 4, 5, how are you going to remember the names? Remembering integer to rational is I can do that, but I can't remember make rational 3 is the one that converts from a double or etc. Make it the exact array. Okay, so make this make rational 2. You mean this? Okay, in that case, you don't have to remember. All you do is just make rational. Well, I mean, if you try to do this, the standard C says that no, a function can have a single name only, and different functions can't have the same name. Okay, that's the story in C, but in C++ it is different. It's called overloading, and in C we are not allowing overloading. No, you have to give unique names to each of your functions. Okay, you cannot give new meanings to your already existing functions. Yes. Call the function, what do you mean call the function? I mean, if I am doing this, make R, okay. If I am printing something on the screen, okay, And if somebody is trying to make hundreds of rationals, and it is getting a few printouts on the screen, how is he going to know that what is causing this problem? That would be a bad thing. And I repeated this many times. Not everybody has nice consoles, right? I mean, console is not something guaranteed to have. Okay. What if I don't have a screen? Okay. Like a car engine computer. Okay. And usually we don't write printfs in our functions unless the function says I'm going to print something on the screen. Okay, so don't use your console to indicate some kind of an error. You may return something, to indicate that this didn't work, right? But what would we return for the rational? I don't know. I mean, what would we return? So that's not a good thing. Maybe I can write such a thing. Let's do this. Okay. Since you're asking that question, why don't we do this and this and this? Okay. I can do this. I will return an integer as an error code. Make rational integer A, integer B, and a rational pointer R. You guys understand what I'm going to do? So I am going to get this pointer from the user. Whoever calls me, they need to give me the pointer to the rational. So what I'm going to do is, okay, take this rational dot A is A. Take this rational dot B is B. Okay. Of course, if B is 0, return -1. Okay. If, or maybe, okay, return -1. Else, return 1. See what I did? Did you understand what I did? Say yes. Yeah. So whoever calls this checks the return value. If the return value is 1, then I am fine. Otherwise, there is a trouble, right? Don't continue. And it is the decision of the caller to make a print screen on the screen or not. Okay. So I can do this that way. Okay. So maybe this would have been a better make rational function. Okay, in object-oriented programming languages, we call these kind of functions constructors. Constructors. And without constructors, you can't make new objects, new variables, new trucks. Okay, you have to have a constructor. Constructor makes sure that everything is fine with the newly constructed variable. Okay, but we are not talking about C++ or Java or C# here. Okay, this C. Okay, but again, we can apply those kind of object-oriented design principles in our C code too. Anyway, so after the make rational, okay, after the make rational, this is interrational, double to rational, rational to double. So it's going to take a rational, it will return a double. Okay, rational, I add two, it will take two rationals and I will add it and return it. Multiply, divide, rational inverse, negate, rational simplify. It will take rational, it will take 2 over 4, okay, and it will return 1 over 2. Is she taking notes or she's browsing? Are you doing TikTok? Yeah. What are you doing? Oh, you are asking ChatGPT, verifying. Okay, good. Okay. So this is rational compare. This is nice, right? So how do you think that this will work? If these two are equal, it should return 0. If this one is less than this one, it should be -1. It's like strcmp, right? strcmp. Rational equals. Okay, they're good if they're rational print. This one is definitely printed. This is rational ABS. It will return the absolute value of the rational. and this is rational power. So I like to take the 1 over 2 squared, which is going to return 1 over 4, right? So those are the whole functions. Those are all the functions. Okay, I took them, and let's look at their implementations, and I put them in a header file now. This is my header file. Okay, rational.h. Whoever whoever needs to use this rational library, they will need to include this header now. When they include this header, okay, all the function prototypes are here. Okay, these two lines I will talk about later. I don't know why did I need this standard Boolean thing. I like to, do I have it anywhere? No, I don't think so. I think I will remove it. Even if I need it, I will get an error message somewhere, then we will add it later, okay? I just removed it. So this is our rational.h, which will include all the header function prototypes about rationals. If you find the string.h somewhere, okay, where is my string.h? Can I find it somewhere? Where are my includes? Okay, includes are usually Explorer. Let's start from this thing and let's go to Ubuntu, this one. It should be inside this user libraries. Okay. User. There is one include directory here. And inside this, maybe these are all header files. Let's see a string is here. Yeah, see this one string is here, right? This one. It's a 20 kilobyte large header file. Let's open it using, yeah, it opened it with VS Code, that thing. So this is the header file. Let's open it using our notepad because I can zoom in. Okay, so this is the C99 standard string header file. Okay, and it defines many things. Memcopy, memo. Okay, well, this one is shared by both C and C++, which I don't like. Anyways, okay, let's go to strlen. strlen. strlen is defined, yeah. Well, I mean, never mind what kind of things it is getting. It says like it takes a constant character string, okay, and it returns a size. You don't know what the extern is. I am going to talk it a little bit. You don't know what the other things are here, but it is defined there, right? So the string.h is defined and it is much larger than what we did. It is more than 500 lines of C++ definitions. So, and whoever needs to use rational, they need to include this rational.h. Okay, but this rational.h, uh, to be linked with my programs, it has to be implemented, right? Before that one is implemented, I like to, why is this empty? This cannot be empty. Oh, that's because I didn't save the other one. Okay, so let's go to rational C, just to type something. Okay, just to type something here and save it. Save it in here. Okay, good. So I saved it now. So I'm going to make a new file. Okay, I'm going to call it rename. Okay, driver rational. rational.c. I am going to write some C code to test that rational code, okay? I am going to write it. So what am I going to do? I am going to do this first. Include first include rational.h. I included it. My integer main. I will make lots of stuff. For example, I will make rational R1, R2, and R array. Let's make array of size 10. Okay. So R1 is make rational 1 over 2, and R2 is, what was the function for the adding to rationals? Rational add. Okay, rational add R1, comma, R1. And then I have print rational, right? Print rational R2. Okay, so this is how I'm going to write it. Okay, this is how I am going to write this as the customer of this library. Do I care as the customer of this library? Do I care? Do I care? Um, these functions, how these functions are implemented? No. Did I care how strlen was implemented? No, right? I just used it. Strcmp is a nice function. Did I know how it was implemented? Well, I implemented it, but I didn't have to know, right? The same thing here. As the customer of this library, I don't need to know. I don't need to know how it was implemented. It is hidden from me. Okay, it is hidden from me. That's called information hiding. Okay, that's called information hiding. Information hiding or procedural abstraction. We try to hide away the details of the function implementations. And we try to hide away the details of, in fact, how the rational is represented in the struct. My customer doesn't have to know about that kind of stuff. The more you hide, the happier the customer will be. Okay. Of course, if you hide everything, then customers can't use anything, right? So you need to hide only the part that the customer doesn't need to know. Okay. So these are the basic principles of in object-oriented programming languages, which you will learn next semester or the other semester. Okay. So that's how we apply them. So when you divide your program, your library into two, the header, which is the interface part, the customer is going to read this header, but the customer will not have access to your implementation. In fact, without seeing an implementation, I did my customer code, right? I included this rational h, okay, and I can compile it, and in fact, this the driver rational will compile. Let's try to compile it. Let's try to compile this driver rational. Okay, go to this one. Okay. So where am I? This one. I have driver rational, rational C, and rational H. Okay. GCC minus C, driver rational. Compile it. What does it say? Compilation rational.h. No, what happened? Why did I get an error message? I have rational H here. Why am I getting the error message? No. Okay, well, I said that my include is a capitalized rational, but my file is a small case rational. So let's go to this one, make it R. Okay, compile it again. Print rational, did you? Okay, implicit. Well, it says that I don't have any print rational function. Don't I have it? I think rational print maybe. What is the name? Rational print. The name is rational print. Okay, let's go there and fix it. Okay. Did you see the error message? It wasn't an error message actually. It was a warning. It said that I didn't see anything print rational named print rational. Since you didn't provide it, I am going to assume that there is a function named print rational will be defined somewhere, but I will assume that it will return an integer, and I will assume that it can take as many parameters it likes. So it was going to assume very bad thing, and it gave me a it gave me a nice warning to that. So I fixed it. Let's compile it. Okay, I compiled it. So what is so I have driver rational.o available. Okay, and if can I run this program now? Can I run this program? I compiled it, right? I have that .o file. Can I run this? I should be making, I must be making some bad mistake here, right? What? We did not implement any of these functions. Okay, so how did the compilation happen then? How can I compile something that doesn't have the function implementations? I compiled what? I compiled only this driver rational function file, this one. I didn't compile the rational.c. Okay, I compiled this one. The compiler says that yes, somebody's going to provide all these rational function implementations later, but I know that they will be there. If I have them, I can link them and I can run. But for now, it is okay to compile this program. It's okay to compile this program file driver rational.c. Can I compile this rational.c? No, because it doesn't have anything in it. It is just simply empty. Okay, it is simply empty. Let's try to compile this. It will nicely compile it because it doesn't have anything in it. Rational.c. See, it compiled it. Did I get? Okay. So rational O, driver rational O. So two of them. Let's try to link all of them together. Let's try to link all of them together. Make our program. Again, I didn't implement anything, but it looks like I can do it. GCC minus O. Okay, GCC minus O. My program name would be rat. Okay. So I am going to take rational O. I am going to take driver rational dot O. What? I get linker errors. It says that you need make rational. I didn't see in the implementation. It also says that you need the implementation of rational add and rational print. I didn't see these implementations anywhere. I cannot link them. Well, you can compile them as they are, but I cannot form a new runnable program to run these because you need to provide all those implementations. Okay, let's go to cloud. Let's go to cloud and let's get the rational.c if I can find it. Where is it? How am I gonna find rational.c? Okay, 4 files says I'm going to give you 4 files. Okay, I have rational.h, rational.c, and it gave me a nice test rational program too, but I'm not going to do that. Okay, let me download all of them. Okay. It will be my downloads directory. Here it is. Let me expand them. This one, extract all. Okay. Files is nice. Okay. So there's rational.h. Where is it? So this is the rational.h. This is the rational.c. Let's let me open it with VS Code. Copy everything. And let's use our notepad again. It is nicer to have. Where is notepad? Not that one, not that one. Yeah, here it is. Okay. Here is my notepad. I pasted everything. Okay. Rational H at the top. stdio, stdlib, and math.h. It looks like I'm going to do some mathematics. I don't know what I am going to do. I don't know. I think it is about power or something like that. Okay. So you don't know what static function is actually. That's why I'm going to get rid of these names. Well, it is easy to tell you, but I don't want to take any side steps. Okay. So these are some helper functions. Those helper functions. Why don't I know? I'm going to keep those statics here. Okay. I'm going to explain them later. Okay. So this helper function GCD, greatest common divisor. I think I asked you this in one of your quizzes. Is that correct? Yeah. Ortak bölenlerin en büyüğü in Turkish. Greatest common divisor. So what is the greatest common divisor of 2 and 4? It is 2, right? Ortak bölenlerin en büyük greatest common divisor. So this one returns greatest common divisor. And this one least common multiple. This one is least common multiple, ortak katların en küçüğü. Ortak katların en küçüğü. And this is how you write the multiply them and divide them by the GCD. Okay, these are two helper functions. Nobody will know that we are using them in our file, but they will be helpful. This make rational. It takes it. Well, see what it does. Did you see it? It sends an error message to the standard error, not the console. Okay. I still don't like it. I like my solution better. What was my solution? Return an integer to indicate there is an error or not, right? So if the denominator is 0, then there is an error. But it chooses the exactly same thing. 0 or 1, 0 over 1, right? It never lets you have an invalid rational. If denominator is less than 0, it makes numerator and denominator both negative, etc. So it just, and at the end, it just simplifies the rational and returns it. Okay, so interrational is this. Exactly your solution. N over 1. Rational to double. Okay. Again, if our denominator is 0, invalid rational numbers, well, you have to do this. Otherwise, I will be in trouble, right? I cannot divide them. This is double to rational. Okay. Double to rational. It's going to take some time, some code to do it because max denominator. I'm not going to look at the implementation. Rational add is just adding two things. This is how it is done. It is AD plus BC over BD. That's what you did, okay? That will be it. Okay. So this cannot be 0, right? This cannot be 0, B times D. Because either B or D is 0, then it cannot be a rational. Okay, so this is the whole implementation. It is more than 300 lines of code. Okay, so again, in your implementation, you include this rational.h. you tell the compiler that I am going to implement all of these functions one by one. This one says that, no, I'm not going to implement anything. I'm going to use them. Okay. So this driver rational is the customer side. Okay. Rational C is the library itself, the library, and rational.h is the header file. Okay. So I am going to now compile this one. Let's save it. Go to the Ubuntu stuff and let's compile rational.c. It is compiled. Let's look at the things. So driver rational is already compiled. Rational.o is compiled and size is 900. Nice. Okay. Rational.o is here. And then I am going to link them together. Rational add and rational print is not there. Oh, I didn't save maybe rational C there, right? I was surprised it is so small. It was so small, yeah. Okay, good. Now I understand bool and bool. We don't know what bool is. Okay, I'm going to change all those. Rational equals Control F. I should return an integer. I'm going to change it. And I'm going to, do I have any other bools? Remember I erased that std bool. It is using a new type that I didn't teach you. And Control F Boolean rational equals, and this should return an integer. Okay, if rational compare returns a 0, okay, this one is going to return a, okay. I think it should compile as it is. Okay. If it is 0, then it will return 1, otherwise non-zero. Let's see. Okay, let's compile. It compiled. Let's see their sizes. So it is not 6,000 bytes now. It is better. And let's link them. What? It say that I can't find this. I can't find this reference to floor. I don't know what that floor is. Floor is in math.h, right? How come it doesn't find it? It compiled, but it can't link. We made another mistake. What is our mistake? What? We didn't link it against the mathematics library. How am I going to do that? I'm going to do it with minus lm. Link it against the math library, right? Remember this one? We did it before. Now I linked it. Now I am all done. Let's run this program. What is my program again? It is ret, this one. Let's run ret. Ret. I think it just printed 1. Why did it do that? Because I forgot what we did. Yeah. R1 is 1 over 2, and R2 is 1 over 2 plus 1 over 2. If you print it, it's going to be, so let's change it to 1 over 5. Let's compile. So what am I going to compile now? What am I going to compile now? Am I going to compile both rational C and driver rational C, or just one of them? What did I do? What did I change? I changed only this one, the rational.c, right? I don't have to compile rational.c because it didn't made any changes. So if rational C is 1,000, or millions of lines of code. I don't have to compile it because my change is not there. So I will driver rational C, compile it. Okay. Now link everything. Let's run ret again. 2/5 is the answer now, right? It's better. Good. So what did I do? I mean, I could have done everything in the same program. This is what I could have done. I could have done get everything from rational, put in my new file, and get everything from main, put in this new file. I have all the implementation, right? I have all the implementation. I get rid of this rational h. Okay, I have all the implementation that about rationals, and I have my main function, and I can compile this new file and run it, right? So why did I have to divide it into 3 files? Rational h, rational c, and driver rational? Because that would be a single time development effort. Maybe I'm going to use this rational in some other place, right? I like to make this a reusable library. Remember, somebody had written string library before, and everybody, including myself, are using this library over and over again. Okay, that's our approach. Try to make them modular. Try to make them different in different places. Let's go to our um, test rational. Remember this test rational thing? Test rational was written by Cloud. Okay, it was written by Cloud, and I guess it is testing everything. So this is what I am going to do. I am going to get this test rational. I put that in my new file. It says just use stdi on test rational.h, and I'm going to give it a new name, rename test ret.c. Well, the name is a little bit different. Okay, so I'm going to compile this one. I am going to compile this one. GCC test didn't I driver I think I didn't save it. What's going on? Okay, save it. I saved it. So I am going to compile it. Test rational. Let's see what happened. As you see, test rational.o is here. So how am I going to link it? Tell me. How am I going to link it? GCC minus O. Okay, ret. Rational O. Driver rational. So tell me how am I going to how I am going to run that program. Am I going to include driver rational.o in here or no? The answer is of course test rational.o. Okay, I linked it. Now the red becomes something different. So it is doing many things like, okay, I am going to do this conversion from rational to double. I am going to make this automatically simplified stuff. So it is testing everything. It is nicely written test code. So what I'm saying is I have two main functions. One of them is in the test rational.c, which is very large one, main function here, this one. The other one is driver rational, which is very simple. Both of them are using my rational library functions. Okay, and you can have many functions, many main functions using the same library. Of course, they cannot be part of the same program. Okay, let's do this. Let's do this. Let's try to, okay. What happens if I do this? Link all of them to get rational.o test, rational.o driver, rational.o. I'm going to link all of them together to make a new program. Wake him up. What happens if I do this? Who's talking? Yeah. It will compile, but it will run what? Would it run my driver rational main function or test rational main function? Which one? No. It will do this. It will say that you are defining main more than once. A C program would have exactly one main function, not 0, not 2, not 3, 1. If you have more than one main function, I wouldn't know which one to run. If you have 0 main function, I wouldn't know what to run. Okay. So if you are compiling a runnable function, runnable program, okay, you need to have exactly one main function. Okay, so having a single main function is one thing. Having many main functions around to test it or writing different programs is another thing. Yeah, you are encouraged to write many main functions to test your programs, but to have a single running program, okay, you will have to have a single main function. Okay, good. Did we understand the meaning of the header files and the libraries? Okay, so this rational.o carries all the information, all the implementation information about our rational functions. Rational.h is the header file that our customer sees it. The customer can look at this rational.h and they can understand what's going on as a customer. What should they do? Which function they should call? But they don't know what's going on inside those functions. That's called information hiding, okay, and procedural abstraction. I give you a printf. You know what the printf does. You don't know how it works, right? That's called procedural abstraction. Again, information hiding too. And in fact, I didn't have to give you this numerator and denominator to use any of them, right? We never set numerator or denominator in any of the in any of our programs, right? We use this make rational function to set them. Okay, so maybe I could have hidden these definitions too. So that makes perfect information hiding. Okay, so when you are writing large programs, you are never supposed to write one large C program that contains 5,000 lines. Your programs, your C code files will include a few hundred lines of code. That's it. If you have 10 C code files in your project, so that means you have a total of 3,000 lines, right? So each of them is going to be a few hundred lines at most. So if your file is getting larger than 1,000 lines, that means what? You are making a logical error, logical design error. Divide that file into two header files, into two implementation files, so that whenever you have a problem, you would know where the problem is coming from. Is it coming from student library? Is it coming from rational library? Is it coming from complex library? And etc. etc. Okay. So that's how they did it. Math library is different from string library. String library is different from standard input output library, and there are many libraries like that in C. Let me ask Cloud again. Let me ask Cloud again. List some of the popular header files in C. Okay, it's going to tell us stdio. It's going to tell us as standard library string stdio. Okay. Um, I'll skip this one. String, the characters type stuff. Mathematics library. This is the complex number implementation, this one. Okay. We never looked at it, just read about it. Time-related stuff. Okay. This is the C99 defines a new Boolean type. Boolean stuff. Okay. Assertion. We didn't look at it. Assertion stuff. Assert, it gives you many standard header files. We have looked at, okay, this one. stdio, stdlib, string, math, C type. I think that will be maybe limits. So maybe 5, 6 of them we looked at them. The rest of them, you read about them. You try to understand what they are doing. Okay, what you do is basically when you develop large programs like such as your project, you are going to write many libraries. Okay, any questions so far? Let's ask Cloud. Why, when you write the rational functions, why did you need to have a separate header file? I am asking this question so to see this answer to justify why do we need header files. Okay, because it is modularity is going to say at the top, right? It's going to be modular, it's going to be easy to maintain, etc. Okay, so code reusability, when you do it like the header files, I can reuse this module everywhere, right? So I can use this rational in this program 1.c or program 2.c. And separate compilation is, don't try to compile everything once. Compile your program, your driver program, and rational in different phases, because they are two different things. One, the errors coming from one is different from the errors coming from the other one. Information hiding, the one that I told you, right? Information hiding that I told you. I don't need to give you all the details about how this rational work. Okay, they are hidden in the implementation file. Okay, optimization and maintenance, the header public API. The header is public application programmers interface. Sources implementation details, we just hide them. Avoid redefining errors. Okay, when you say okay, when you do this, make rational, many things. But in that case, you make a small error, and that small error is something that you need to fix. But if I include it, I don't have to do that error. Okay, those are the things that cloud is. Those are all nice. Those are all nice. Okay, so any questions about the other files? Okay, what did I say at the beginning of the lecture? I said that I would talk about okay, using abstraction to manage complexity. I talk about procedural abstraction, right? You write functions, okay, to hide details of how the things are done. And they are modular, and I can use them in any place I want. I do this data abstraction, such as the one that I used in rational. I define this nice type def, struct type def. So in fact, the customers won't have to know the details of what's going on inside my struct. And information hiding, again, I hid details of implementation in my implementation file. Reusable code, ChatGPT talked about it. So my personal file, header files, and implementation files, I talked about them already. So let's talk about this conditional compilation. Okay, I don't have much time for it. Today you will have your quiz. starting at 10. I think I will stop at this point. I will continue on this next week. But I still have 5 minutes, right? Okay, let me show you this. Let me show you this then. Let's go to rational driver rational.h. What happens if I do this? I am including this rational.h 2 times. What happens? Okay, let me compile this. Rational driver rational.c. I'm going to compile it. Well, nothing happened. It compiled nicely. It means what? I can include the same thing 2 times. Isn't that a problem, you might say? Well, it is not a problem anymore because I have these guards at the top. This is called conditional compiling. Okay? The sharp sign at the beginning, it says, remember we did this before, if not defined. Remember when we did the debugging? If not defined debug, then do this and etc. It says that if rational.h, if you did not see it before, just define it and do all of them. And at the end, I have this endf. If you have seen this before, don't define it and don't do any of these. So if I include this rational.h once, it will be defined and everything will be read. But if I include it the second times, since I have defined this rational h before, right, it will not go into this if statement, conditional compilation if statements. That's what we did. That's what we do all the time at the top of header files. We said if not defined rational h or whatever your header file name is, just define it and put everything in it until the end, okay? And at the end, you put this endf that defines this rational h, okay? So if I collapse it, that's the whole thing, okay? That's the whole thing. Okay, so that's kind of an introduction to conditional compilation. I didn't tell you everything, but that's the meaning of those two things. And everything, where is my string.h? Where does string.h go? Okay, is it this one? Oh, string.h is here. See this one? It has the same thing too. If not define string h, then define it. So you can include string.h more than once, no problem. But if I don't have it, let's make that mistake. Erase these two and erase this one. Save it and let's compile it again. What kind of error? I'm going to get an error message, right? What kind of error I'm going to get? Tell me what kind of error I'm going to get. Why is it hurtful to include the same error 2 times? What did I have inside rational.h? I have a type def struct definition, right? If I try to include this 2 times, if I try to define this 2 times, it will give me an error message saying that you have already defined it, right? So that's what I'm going to get. So it says many things. We are trying to find the same thing many times. That's what it says, okay? So conflicting types of rational have struct. You already did this and you are going to do it again. Okay? So make rational into rational. So these are all okay. You did this before and you're trying to do it again. That's not a good thing. That's why I just put them in and I compile it this way. No problems now. So you might say, why are you including this rational.h 2 times? Don't include it. Sometimes we have to include this because This include might be inside another include, okay? And I have to include the second one. So one of them is including the other one. I am including the original one. Sometimes it is not easy to manage, okay? So we do this all the time. Okay, I think that will be it for today. In 10 minutes, we will have our quiz. Okay.